Hello dear students. Now let us see conversion of decimal numbers to the binary, octal or hexadecimal number. So for this purpose let us consider the example to convert the decimal number 861 to either binary or octal or hexadecimal number. The first step to convert decimal number to any of these number system is to divide the number by the base value of the destination system, that is 2, 8 or 16, and note the remainder and quotient. That is, if we want to convert this number 861 by to binary, then we have to divide it by 2. If the number 861 is to be converted to octal, we have to divide it by 8, and if the number is to be converted to hexadecimal, then we have to go on dividing that number by 16. Uh, Divide the quotient that we obtained in the first step. So we have to again divide that particular quotient, and we should note again the remainder and the new quotient. So this process is to be repeated until the quotient is less than the base, that is 2, 8 or 16, or eventually that particular quotient becomes 0. The third step is arranging remainders in the reverse order of they obtained gives the number represented in the binary, octal, hex number system. So this is how we convert it. So let us take the example. So for that purpose, let us first convert the number 861 to binary. So because it is to be converted to binary, we divide this number 861 by 2. So dividing 861 by 2, we get 430. The quotient is 430 and the remainder is 1. So we note the quotient as well as the remainder. Then the quotient is again divided by 2. 430 is the quotient, it is again divided by 2, and the new quotient and remainders are noted. The new quotient is 215 and the remainder is 0. So like that, after dividing 215 again by 2, we get the quotient 107 and remainder is 1. After dividing 107 by 2, we get the quotient 58 and remainder is 1. After dividing 58 by 2, we get the quotient 29 and remainder is 0. So after dividing 29 by 2, we get the quotient 14 and remainder 7. So like this, 14 by 2, quotient 7, remainder 0. 7 divided by 2, quotient 3, remainder 1. 3 divided by 2, quotient 1, remainder 1. We can again divide this particular 1 by 2. In this case, now the quotient will be 0 and remainder will be 1. Now if we arrange these remainders in the reverse order of they are obtained, so we have to start from this particular one. So 1 1 1 0 1 0 1 1 0 1. So if we note this, then what we get is the binary equivalent of this particular decimal number 861. Now let us go for conversion of this 861 to octal. So this particular conversion, uh, we divide this particular octal number, decimal number by 8. So quotient is 107 and remainder is 6. Then we divide that quotient 107 by 8 again. So the new quotient is 13 and the remainder is 3. 13 again we divide by 8, quotient is 1 and remainder is 5. Then at last we divide 1 by 8, the quotient will be is 0 and the remainder is 1. So if we take this particular remainders in the reverse order, so what we get is the octal number 1536. So the octal equivalent of the decimal 861 is 1536. And at last let us consider convert this 861 decimal to the hexadecimal. Here it should have been hexadecimal. So we divide it by 16. So quotient is 53 and remainder is 13. Then we divide 53 by 16, the quotient is 3 and remainder is 5. And at last we divide 3 by 16, the quotient is 0 and the remainder is 3. So we take the remainders in the reverse order, 3, 5. We have to represent this 13 in hexadecimal and it is D in hexadecimal. So the number becomes 35D in hexadecimal. So like this, the 861 in decimal can be converted to the hexadecimal, which is 35D. So we come to the end of this particular first topic 1.1 number system. This is the next topic, Boolean algebra. If you have any doubts, you can ask the questions or you can share your responses. These are the references.